Hello, we are Group 42, formed by Jaume Miquel, Chao Wei, and me, Noah Zafra, and this is our video about the PLA 1011. Here you can see an image with the final goal of this PLA, that is a simple calculator for 8-bit BCD numbers as integers. This block diagram shows the working of a 16K matrix encoder, which takes inputs from a 4x4 keypad and outputs a 4-bit hexadecimal code corresponding to the key pressed. This 4-bit represents the next value of the key was pressed. For example, if Ka corresponds to 0 per A, the output will be 1010. And the GS pulse is active while clicking. That is a representation of the keypad inspired by one in Proteus. In this slide, you can see the different names in hexadecimal for each column and each row. That is the hardware circuit connections to pins. The goal is to convert the keystrokes into interpretable digital signals. The main components are the matrix keyboard, resistors, capacitors, microcontroller, and 460 kHz clock. You can see the software organization with the read inputs function that captures input signals, the state logic that processes data based on the system state, and the output logic that generates the necessary outputs. And when a clock edge is detected on int 0, the program jumps to the interrupt routine.
Corta, por si me equivoco, no tengas que grabar. This is the representation of RAM variables. The variable current state shows the ASCII codes for capital letters. The variable GS signals is 1 when a key is pressed. Then the variable row scans rows of the keyboard. For example, 1110 says that RO is activated. The variable columns capture the values read from columns. And then the variable data contains the values of X of the pressed case. This hardware-software diagram is fundamental to show and explain the main blocks conforming this FSM application. The zone in green represents that the part works with C, libraries, and RAM variables. Main state, scan rows, checks if a key is pressed and in which row. ENC row state in which an active key is detected and the data is encoded. When GS is 1, a key has been pressed and its value is stored in var data. In var columns is different from 15. It indicates an active keyboard input. And in var columns is equal to 15. It goes to the next state. Port configuration. Trees A, trees B, and trees C. Indicate the pin configuration. 0, it means that it's configured as an output, and 1, it means that it's configured as an input. Port A, port B, and port C, they represent the current value of the microcontroller pins. Some pins have a mark or represent with an X or don't with a point, indicating their status. Here we can see that state logic truth table with the different options for the var columns. the corresponding var current state and the next state. Also, when we can see the corresponding flowchart of the function ready for C translation. Here, we can see the truth table of the output logic function with the column variable, the state, the GS data, and the different rows. Also, we have their corresponding flowchart showing that information. In this picture, we can see the simulation in Proteus step by step, showing with 000.
Okay, after that, we continue with the design phase, part 2, where we wanted to implement the LCD display to show the data in the screen. In this slide, you can see the C files and the H files for the MP Lab X simulation, and also we design the same files for the LCD element. After that, we design we put it in the MP Lab and we get the .conf and .hex files to insert it in the microchip. And we designed the Proteus project, which is that where you can see the keypad, the LCD display with the screen, and also the chip. After that, we can't make so many conclusions since we didn't finish the last phase, and we worked the project till the phase 2, which is this one, but it doesn't work correctly because of probably because of errors in the files of the MP Lab. So we couldn't solve them, and we decided to stop here because we ran out of time. Even though we think that the design of the Proteus project and the theoretical part are not poorly developed, so in that sense, we are satisfied with the work that we have done. Finally, we would like to emphasize that we would have liked to be able to finish the project, but due to that we weren't able to solve the problems, we couldn't. So this is all we have. So thanks for your attention.
Thank you.
Goodbye.